record because I was okay. All right. Thanks for the reminder. Okay, so does anyone have like a preferred method? Would you rather use elimination or substitution? Are you fine with both? I just want to see if like anyone
I
only
generally
prefers
use
one.
both. I
Both?
generally use both. However, if one of the equations is simple, as in
Mm-hmm.
like, I normally use substitution for that one.
Okay, great. That's a good point. Thank you for bringing that up. Okay. So I know some people have a preferred method, like maybe you only like elimination, or maybe you only like substitution, or it seems simpler. But the one thing that you should take into account is the equations themselves. How do they look, right? Just like we've been taught. Like look at the equations. Which one looks simpler to do with one method or simpler to do with the other method, right? And this should take you just like a couple of seconds. It shouldn't even 1 second, just to like glance through and see which one would be easier to do with a certain method, right? Okay, so now let's look at them independently. What should make you use elimination and what should make you use substitution, right? So for elimination, we said you are either subtracting the system or adding the system to get rid of one of the variables. So what should make you use elimination? So what makes elimination fast is if none of the coefficients in the system is 1. And just to clarify, when I say coefficients, I'm talking about the A, B, D, and E. I'm talking about the numbers that appear before the variables. So if you're looking at this system and you can see that none of the coefficients is 1, elimination would be faster. And the reason is, if you have a system where none of these is 1, let's say we take the first one, we have ax plus by is equal to c. If you try to make x the subject of the formula, you're going to end up with a fraction, right? It's going to be c minus by over a, because a is not 1. If a is 1, you're simply going to have c minus by. I mean, if a is 1, sorry, you're going to have c minus by. But if it's not, you're always going to end up with a fraction. And fractions are it's not that they are impossible to solve, but they do take more time, because then you have to think of the common denominator and all those different steps that come in with using a fraction. So if you prefer substitution, so if you prefer elimination, okay, that's for the next part. Anyway, let me just say it's easier, it's a faster method when none of the coefficients is 1, because then you've already eliminated 1, so you don't have to deal with fractions, and it just makes the process much better. And if you find that none of them are equal, A, D, B, and E, you can simply use a factor to multiply throughout and make it equal. So let's say A is equal to 3 and D is equal to 2. So you have 3x plus by, then 2x plus ey. You can multiply the first equation by 2, multiply the second equation by 3, just to make x equal in both. And that will simplify the system that you have. And you can easily subtract and get rid of 1. And then you would be left with the values of y. And that's one thing to keep in mind, that the one you eliminate is not the one you're going to find first. So just keep that in mind, that if you eliminate x, obviously the first value you're going to find is the value of y. Okay, so that's when elimination is faster. And like I said, it's just because if you try to do substitution, you're going to end up with a fraction, and that will take you more time compared to just using the elimination method. So that means that the opposite is true. If one of the coefficients is 1, then substitution would be, and this is very relative, but substitution would be faster, because then you can simply make it c minus by is equal to x. There's no fraction anywhere. And you can easily just plug it in to the second equation and then find the value of y. Okay, so if you really love substitution, which is where you make 1 the subject, if you really love substitution, but then you find that none of the coefficients is 1, then you're going to waste your own time by having to deal with fractions. So if you're not comfortable with either one of these methods, make sure that you do get comfortable, so that when the situation calls for it, you can use the other method, right? So just make sure that you are okay with both and you're able to do them. They're both obviously very simple methods, but like I said, time is part of the exam. So you're really trying to be as fast as you can. So are there any questions so far or any additions?
No, ma'am.
All right, great. So let me clear this. Okay, and then the other thing to note when we're looking at elimination, I feel like most of the examples that we look at usually don't have equal coefficients in both, right? Like I said, maybe you can have 3x and then 2x in the other equation and you can multiply. But you can still use elimination if one of the coefficients is already equal. Let's say you're given x and then x in the second. So maybe you have x plus 2y and then x minus 3y. You can still directly just add and subtract. So I want you to think of the multiplication of the factors as like an added step sometimes, right? If you have 3 and 2, it's only sometimes that x is not equal. So if x is equal, you can just go ahead and add, or you can just go ahead and subtract as long as you get rid of one of the variables, and that will make your work very easy. So that's just something to keep in mind, that if one of the coefficients is already equal, it's very easy. It's very easy for you to just subtract and add. And that would obviously be the fastest method if one of them is already equal in both equations. So just keep that in mind. So if you do come across a system of equations on an exam, the first thing is check the coefficients, because that's what we are using as a standard. Check the coefficients. Is any of the coefficients 1? Okay, substitution would be okay. Or do you have a situation where none of the coefficients is 1? Go for elimination. So that should help you just like figure out generally which one is faster. Like I said, this is relative. Maybe you're just able to solve faster when you're using elimination and so on. So this is just advice to help you figure out which method would be better. I would say the case that can't be argued is the last one I talked about, where one of the coefficients is already equal in both, because you just need to add or subtract and you've already found the answer. So just keep that in mind as you go through. Okay, so we've dealt with the first two. When do you use elimination and when do you use substitution? Okay. And then when you're dealing with a system of equations, there are certain situations that can categorize different systems of equations, right? So only look at some of them that are tested on the SAT. So the first possibility is you can have a situation where you have an infinite number of solutions. So that means any value of x and any value of y can satisfy that equation. And there's only one thing that can make that happen. So I want you to think of that these are just categories of systems of equations. So this is the first possibility. You can have a situation where you have infinite solutions, right? So the first thing I want you to remember is that when we're looking at a linear equation, we're looking at a line, right? So if you have ax plus by is equal to c, this is obviously an expression that tells you what value of x and what value of y gives you c, but this is also a line. As long as you have x and y, or even x alone, y alone, you're dealing with a line, right? So in terms of categorizing the systems of equations, I want you to think of them in terms of lines, which is why we are kind of shifting. So we're kind of moving away from looking at them as equations to looking at them as lines, because that's what they are. And also keep in mind that whenever you solve an equation, you're actually finding the place where those two lines meet. Yeah. Okay, so if you have a system that has infinite solutions, it means that you have the same line, right? It means that every point on this line is also on this line. So basically, it's like having two lines drawn over each other. And I'm starting it this way because I just want you to understand what they mean by infinite solutions, right? So it means that you have the same line. Every point on one line is also on the other line. So instead of you being able to find like one point where they meet, every point is a solution, right? And obviously, for two lines to be on each other, it means that it's the same line. So two equations are going to have infinite solutions when you're dealing with the same line, right? And we know that an equation, one of the rules of equations is when you do something to the left-hand side, you also do it to the right-hand side. So it's possible to have two equations that don't look exactly the same. What do I mean? You can have x plus y is equal to 2. You can have 4x. Okay, as long as you know what I'm talking about. 4x plus 4y is equal to 8. Look at these equations. They don't look the same, but if you multiply the first one by a value of 4, you're going to get the second equation. Right? And this is the rule of equations. These two are the same. Even if you multiply throughout by 4, as long as you've applied the number 4 to every term in the equation, you still have the same line. Right? So if you have a situation where you have a line that can be obtained by manipulating the other one, and by manipulating we mean by applying a factor. Like in this case, we multiplied the first one by 4. So we can obtain the second equation by multiplying the first one by 4. It means that these are the same line. And the rule of thumb is that as long as whatever factor you're using applies to every term, then it's the same. It's the same line. And this is a concept that we learned the first time we learned about equations, that if you multiply throughout or you divide throughout, you still have the same equation. Okay, so when two equations are dependent, one can be obtained by manipulating the other one, and they will have infinite solutions. So how is this tested on the SAT? So I hope you guys get the concept. Just the fact that it's the same line, but you have different mirrors. It's the same line, but the second is just multiplied by a certain factor or divided by a certain factor. So the way I've seen this tested, I remember one question that was 2x plus, these are not the same values, but yes, 2x plus by is equal to 4. And then the second system is 4x plus 8y is equal to 8. So you're given this system and you're told this is a variable b, right? So you have 2x plus by is equal to 4. And then you have 4x plus 8y is equal to 8. And then you're asked what value of b is going to make this system have infinite solutions. Doesn't anyone want to give it a try?
I'll try it.
Go ahead.
Any question?
Sorry?
Can you repeat the question?
The question is, you have this system. So, sorry, there's a lot going on the screen right now. Let me put it in red. Give me a second.
The value of b for infinite solutions, right?
Yes. What value of b will make this have infinite solutions?
4.
Did you say 4?
Yes.
Great. So how did you get 4?
How did I do it?
Yes.
If we look at the y values as well as the constants, we can see that the latter is a multiple of 2 of the third, deducing that b must be equal to 4.
Thank you. Great. So I hope we get the concept, right? I wanted you to understand it from a line point of view because it makes you see why you're doing what you're doing. So what we're basically doing is seeing, okay, what factor has been applied to the first to give us the second equation. And we can see, looking at the values of x, we multiplied by 2. Looking at the constants, we also multiplied by 2. So it means that whatever value of b is the value, we have to multiply that by 2 for us to get 8. And so we end up with 4. Okay, so it's only possible to have infinite solutions if you have the same line, and you can only have the same line if you have the same equation, meaning that maybe there's a difference of a factor, but it's still the same line. So do we have any questions?
No, ma'am.
All right, great. If a question does pop up, please let me know. Okay, so infinite solutions only come in when you have the same line. It might look different because of a factor being applied, but because it's an equation, it's still the same line. Okay, so that's one category of a system. It's possible for you to have infinite solutions. The other category is it's possible for you to have no solutions, right? These are lines. It's possible that one is going that way, one is going that way. These two are never going to meet, no matter how far you stretch in each direction, okay? Now, the trick about this is if you have lines that are bending towards each other, let me put it, okay, let's say you have a line like that and a line like that. If you have lines like this, eventually, as they extend, they're going to meet because they're kind of bent in the same direction and they stretch in both directions. So this applies no matter which side one is bent. Either way, they're going to meet at some point in the axis. So the only thing that's going to make them not meet is if these are parallel lines. And I'm sure maybe that was the definition of parallel lines that you had. I remember my definition was lines that never meet. So parallel lines are going to keep going in the exact same direction. So there's no way for them to meet because at every point, they're both moving in the same direction. Okay, so keep that in mind. For equations not to meet, it's only possible if they are parallel. And that takes us to the next concept, which I hope you guys are familiar with. Y, let me write this again. Y is equal to mx plus b. It's getting harder and harder to write for some reason.
Yeah, I've heard of that equation before,
Mhm.
except for when my math teacher taught it to me.
Mhm.
The thing was, it was y equals mx plus c.
Oh, okay. Yeah. So the only thing is this should be a constant number. So it doesn't matter whether it's B or C or D or F or Z, as long as it's like a constant. Yeah. Okay. So this is the general form, and we'll come back to this when we move on to the next concept. But this is the general form of an equation. And it doesn't matter how the equation looks or what numbers are involved, as long as it has y and x in it. If you arrange it in this format, you're going to have y is equal to mx plus c, and the m and the c are very important, right? So as I said, we'll come back to this concept because it's very important. But m represents the gradient, and c represents the y-intercept. So we'll come back to the c later. For now, we're focusing on the m, right? Because we said for you to have lines that don't meet, they have to be parallel, meaning that m has to be equal. M has to be equal for them, but C has to be different. Because again, we said, if you have a line and the same factor is applied throughout, you're going to have the same line. So what I mean is, if M is equal, if M is different, but if the same factor is applied to C, you're still going to get the same line. So we're trying to find a situation where these lines are not the same and they don't meet. Because for them not to meet, they're not the same line. So I want you to keep in mind that M should be the same, but C should be different. Because if C is different, it means that those two lines are at different points in space and they're not the same line. So M should be the same and C should be different. So if you have lines that don't have a solution, C should be different and M should be the same, right? And this is only because they are parallel. That's why M is the same. C because they are different lines. Okay. And so how do you apply this to a system? And you don't have to make, make it into this form for you to be able to see, because as long as Y is alone, the coefficient of X is going to be the gradient, as long as Y is alone, right? So if you have a system of equations and you're looking at it like this, you're basically trying to make sure that the constants are different, right? You're seeing, okay, the first parts are the same. The first parts are the same, and this part is different. And again, it's possible for you to have a factor multiplied, throughout, and we still apply the same concept of equations, but still, sorry, give me a moment. So we're still applying the same concept of equations, but now making sure that C is different instead of it being the same. So I want to give an example and see if the concept is clear. So let's say we have 2x plus, we'll still use b, oh no, we'll make b the constant. Let me erase this. Okay, let's make it by is equal to 4. Then we have 4x plus 8y is equal to 5. Okay, so if we're being asked in what situation does this system have no solutions, we're basically doing the same thing that we did previously, because we're making sure that the x and the y are the same. So again, the answer would be 4, right? Because we're multiplying this by 2 to make sure that the y's are the same, but these are going to remain different. So our goal becomes now to make sure that x and y are the same, but the constants are different. So even if we were to multiply this by 2, we're not going to get 5 on this end. And this can be tested in different ways. Maybe the constant can be the variable, like they ask you 2x plus 3y is equal to b, But just keep in mind that you have to make sure that the constants are different while the x and the y remain the same, so that you're still applying this concept, but you don't have to make it into this form, y is equal to mx plus c. That would be unnecessary, because then if x is the same, y is the same, then y and mx will be the same. And so C is what you're targeting. C should be different. Okay, so do we have any questions?
No.
All right, great. So we've looked at 2 categories of equations. It's possible for them to have 1 solution, in fact 3, because we started with the first possibility. If we're using elimination or substitution, we're saying those lines meet at 1 point. So it's possible for them to meet at 1 point. Second scenario we looked at is that these 2 have infinite solutions, meaning these 2 are exactly the same line. Third possibility is these 2 have no solutions, meaning that they are parallel. So just keep in mind these 3 different possibilities. They are going to explain in the question what they want you to do. Maybe they just want you to solve. Maybe they want you to find out what will make them have infinite solutions or them have no solutions. But as long as you understand why, from the standpoint of a line, that will help you. And I am not a person who likes memorization. I'm sure you've noticed in how I explained that I try to break down the why, so that in case you forget, you'll still be able to figure it out, right? Because you remember, oh yeah, for them to have no solutions, they have to be parallel. And then you'll be able to analyze and say, okay, what makes them parallel? Or what makes them have infinite solutions? So just remember to think of them in terms of them being lines, and that should help you figure out like the next step to take from there. But understanding that will really shorten your process, because then you know what your target is. Like if you know they have infinite solutions, your target is making sure that everything is the same, but just multiplied by a factor. If you know that they have no solutions, your target is the constants. Are the constants different, even though the first parts of the equations are the same? So just keep that in mind as you handle equations. Okay, the next tip is just a tip to help you solve faster. Like I said, time is really of the essence. So I mentioned that dealing with denominators can really waste your time, because you have to find, the common denominator and then multiply, cross multiply, and then, it just adds unnecessary steps. So I want you to keep in mind that it's possible for you to clear all the denominators. If let's say you have, let's say you have x over 3 plus y over 6. is equal to 1/9. If you were to use the long root, you would have to find the common denominator and then divide, after you find the number, and then cross multiply, and then put the terms on one side. Like, that's really a waste of time, as opposed to you getting rid of the denominators. So as you get rid of the denominators, think of finding the biggest number that can go into all of the denominators, because then all of them are going to cancel out. Sorry, did someone say something?
Yeah, I said just multiply everything by 9 into 3x plus.
Great, thank you. Right, so if you multiply everything by 9, that gets rid of everything because it cancels out with the 3. As you said, yeah, that gives us 3x. And then multiply by y/6, that also cancels out because 3 goes into both 6 and 9. That would be 2y is equal to, and of course the 9 cancels out with the 9, that gives us 1. So it's not going to give you the answer, but it's definitely going to speed up the process of you finding. So I want you to just keep in mind that fractions are a lot of work, and if you can avoid them, avoid them, because
I
they
think we
will
made a
take time. Did someone say something?
I think we made a mistake.
You may have what?
I think we made a mistake.
Where? In the multiplication?
Yeah.
Oh, I see. The 6, right? Yeah, thank you for that. Thank you for that.
It's better if we use something like 36.
Yes, yes. Thank you, thank you. Great observation. So that wouldn't be able to, so it's not, it's 6 isn't a factor of 9. That was the problem.
Maybe we could use 18.
18? Oh yeah, 18 is smaller. Great, I'm loving this. Okay. Is there a smaller number or is 18 the good?
18 is the best we got. 12 is below, but 12 isn't going to solve the problem.
Yeah. 12 9 isn't a factor of 12. Okay, great. So now if we, same concept, if we still divide, the 3, the 18, we're going to get 6x. Then that would be 3y is equal to 2. Thank you for that. That was a mistake.
No problem.
Okay, so we are basically trying to find a number that all of these are a factor of, and that should get rid of,
Excuse me.
later.
Excuse me.
Yes.
Oh yes. I was saying that this method that we're using with the multiplication, I got the same exact answers using the LCM method.
You mean finding the lowest common denominator of the fraction?
Yeah.
Oh yeah, definitely. That's definitely the goal, right? We're trying to find the number, because that would be like 3 into x would be 6x. I mean 3 into 18, sorry. And then 6 into 18 would be 3y. So it would definitely give us the same answer. It would just be a longer process. So let me erase this. This is not very clear. Okay, so let me show you what I mean, right? So here in the multiplication, the biggest job was finding the number. Once you found the number, it was just multiply, that's it. If we use the LCM method, we have to think, okay, what number is the lowest common multiple of those 18? 3 into 18 would be 6 times x, 6x, plus 6 into 18 would be 3, multiplied by y would be 3y, is equal to 1/9. Next step, multiply, cross multiply, and then that will cancel out the 9. And we still get the same, but I'm sure you've noticed that we had to do more steps. In order for us to find the answer, we had to find the LCM, divide each term separately, and then add, and then multiply, cross multiply, and then reduce it. So it just gives us more steps compared to using this method. So it's not that finding the LCM is like long and you should avoid it at all costs. It's just, this is just a by the way, maybe this could be faster. So like, it's just something to keep in mind when you do come across a question that involves fractions. But both methods work. They definitely work. Yeah. Okay. Any questions?
Oh, ma'am.
Great. Thank you. Okay. So the next part has to do with you having an independent equation. And normally when one equation is being tested, they won't just give you, like I said initially, you would need two variables. I mean, if you have two variables, you need two equations to come up with the answer. That's the that's the rule for equations, right? But if you have one equation, you're not going to be asked to solve it because you're not able to find the values of x and y. But these are conceptual questions. So they try to see, do you really understand what an equation is? Do you understand what the gradient is? Do you understand what the y-intercept is? And I already mentioned that, right? M is the gradient, B is the y-intercept. And you would find that most of these are word equations. They'll give you a whole sentence explaining how the equation came about and then ask you to find some information from the equation. So this portion of the session, we're going to be looking at what M means in real life and what B means in real life, right? So in terms of you having an equation, again, we think about it in terms of a line, because sometimes you have to deal with lines as well. So you have this line, which is y is equal to mx plus b. Let's say it meets the y-intercept at 1. I mean the y-axis at 1. And it has a gradient of, let's say, 3. Okay, so normally when you're dealing with questions that ask you about the meaning of m and b, they'll give you some real value to represent y and some real value to represent x. And you find that most of the times x has to do with time. Or let me just say all the time, because I haven't seen any question that doesn't have x as time. So it can be days, hours, minutes. So let's give an example of an equation that represents how much money you have to pay for renting a boat. And y represents the cost of renting the boat. X represents the time. So you're being charged per hour. So let's say you have to pay $12 an hour for renting this boat. And X is in hours. Sorry?
I can give an example.
I didn't get what you said.
I said I can give an example real quick.
Oh, yeah. Go ahead.
All right, we say like 50 plus 100 equals 50 plus 5y.
50 plus what?
Where 50 plus 5y, where
Mhm.
100 is the total cost, 50, which would be the y-intercept or the down payment, and 5y, y would be the rate or the hourly rate that will come up with the rest of it.
I think I missed the equation. You said 50 plus 5y?
100 equals 50 plus 5y.
Oh, okay. I see what you mean. Okay. 100 equals 50 plus 5y. Oh, okay. I see what you mean. So like basically 50 is the down payment and then oh, sorry, my battery is low. Give me a second to plug it in. Okay. Sorry about that. My battery was about to die. Okay. So we have 100 is equal to 50 plus 5y. Sorry, could you make sure?
In addition, the 5 is the rate.
Sorry, you said 5 is the rate?
Yeah, 5 is the rate. Say it's day. It's $5. It's $5 a day.
Oh, okay. So it's $5 per hour.
Yeah, or per day. Anyone will go.
And then 50 is the base payment.
Yeah. So if you only have $100 to spend, you can only use boat for 10 hours or 10 days.
Great. Thank you for this. This is a great example. I will keep it right here because you brought up the aspect of a base payment, which is very important. And normally, when you're tested on this, they'll either ask you for the base payment or for the amount per hour, right? So now we're going to break down. So we have an example where we have y as our variable. So we're going to break down an example where we have both x and y. But definitely the same concept as this. So we'll keep this as our example, right? So imagine we have a line. This line has y and x. X represents the total cost of renting the boat, and y represents the cost of renting the boat. X represents the number of hours that the boat has been rented. So imagine you've been told that you've been given this equation, y is equal to 3x, or let's keep the numbers. Let me change this to 5. Okay, let me erase this. So let's make it 5y plus 50. So the concept I want you guys to understand is there's only two things you can get from an equation: the m and the b, or the c, whichever one you want to use. So you can get the gradient or you can get the y-intercept. Those are the only two things you can get from a single equation. And for you to get those two things, your equation has to be in this form. Y is equal to m. Sorry, this should be x. Sorry, let me replace this. So we're looking at y representing the cost, the total cost, and x representing the number of hours. So it's definitely this example, but we're just switching the variables around. So I'm making x the hourly rate. And then it makes sense, right? Because if we're looking at the gradient, we're going to divide y by x. That's the formula for the gradient. Y step over the x step, meaning we're essentially finding how for every unit you rise in y, how much are you moving in x? That's what the gradient is. Now, if you look at this if you look at it in terms of a line, and y is the cost and x is the time, it means for every time, for every hour you move in x, how much is the cost rising in y? So it's basically the y per x, the cost per hour. So I want you to keep that in mind whenever you look at an equation like this, that your gradient is your cost per hour. And that would definitely clear everything up, because just looking at this, you're multiplying 5 by the number of hours. So that means that for every hour, your cost is rising by 5. And so that's your gradient. So your gradient is your y per x, your y steps per x. And that's going to depend on the situation that you're given in the question. If it's renting a boat, like our example, it will be the cost of renting the boat per hour. If you are, if you're looking at, I don't know, the number of, let's say how much you pay for, I don't know, taking a walk in a park, that would be per hour you spend in the park, how much are you going to spend? But I'm using this example specifically because this is normally how the situation will be. X will be time, Y will be the cost. So just keep in mind that X is usually time. And so when you look at what's being multiplied by the time, it's going to be the cost per time. So if you're given X in days, it will be the cost per day. If you're given cost in weeks, it will be per week. So just pay attention to the X that you have, and keep in mind that whatever is before the X is your Y per X. And then if we imagine that X is 0, meaning even before the number of hours increase, you already have 50, right? That means that this is your base payment, as in the example we had, right? This is the base. Before any number of hours are added, you would have to pay that much. So it's basically like you paying for getting the boat. And then for every hour that you spend, you have to pay $5 more. And so if you look at the representation in this diagram above, the intercept, so this would be our 50. So the intercept represents the point when the line meets the y-axis. And on the y-axis, x is 0, right? meaning the number of hours is 0. So that's going to be your base payment, even before even before the hours move. How much are you going to pay? So that's that's what your equation represents. So remember that your M, or your coefficient of X, is your Y per X. And remember that the number that's alone, the independent variable or the constant, is going to be your base. And it makes sense if you really understand this equation, right? Imagine you're told you're going to be paying 5x plus 50. This 50 is not affected by x, meaning it's just going to be the base. This 5 is affected by x, meaning that the longer you spend, the more number of 5s you have to pay. And so it really, if you look at it like from this point of view, it really adds up and makes sense that this would represent the total cost of renting the boat. So do we have any questions? Sorry, I didn't get that.
No.
All right, great.
No, ma'am.
Yeah, I have a question.
Go ahead.
So the five there will be like $5 for that's the hours that you have. The $5 are the hours, and
Mhm.
and the 50 you would have to pay $50 after the 5 hours. So say 1 hour is like $10.
So you've explained it really well, except that you switched one part, like which one comes first. So we said that the X represents the number of hours. So if you have 1 hour, you're multiplying 5 by 1. So it's $5 per hour that you have, right? So if you multiply 5 times 1, which is our X, we're going to get 5 plus the 50. So 50 stays no matter what. 50 is like the amount that you pay for you to even get into the place where the boat is, right? So you pay 50 first. So 50 is your first, 50 is your base payment. It's like your down payment. So you pay the 50, and then you're going to now add 5 for every number of X, the number of hours that you spend. So if it is 1 hour, we would have 55.
Okay, so you pay the 50 to get the boat.
Yes, yes.
Okay.
Yes. So it's always your base, and it doesn't involve the number of hours. So it means that it's your base, like before you even do anything. That's the amount of money that you paid. Yeah. Any more questions? Okay, so I want us to go through some questions and apply what we've learned. Okay, let me stop sharing. Okay, so as usual, we'll be using the first practice test. Can you guys see my screen?
Yeah, no problem.
Yeah.
Great. So we'll be using the first, like I mentioned last week, I don't want to like exhaust you guys' practice materials. So I'll stick to the first so that you guys have the rest as your practice. Okay, so question 1 has to do with you understanding the format of an equation. So we'll go through question 1. It says Tilly earns P dollars for every W hours of work. Which expression represents the amount of money in dollars Tilly earns for 39 hours of work? What do you guys think? Is it 39P, P over 39, P plus 39, or P minus 39?
Miss B.
B? Okay, we have a B. What does everyone else
Yeah,
think? D?
Choice A.
I go for B.
B? Okay.
I say choice A.
A? Okay. Any other answers? Okay, I see an A in the comments. Okay, so let's go through. So we've been told that P dollars is earned for every W hours of work. So that already tells you, I want you to think of it in terms of X, right? X is your hours of work. So if I tell you that you're going to earn $5 for every hour that you work, it means you're going to multiply P times W, right? If I tell you it's $5 every hour and you work for 3 hours, you're going to get $15 because that's $5 for every hour that you work. So it's kind of like the gradient, right? Our Y per X. So the first thing is if it's P dollars for every hour, we'll have to multiply P times W for us to get the total number of hours. And then now we're told which expression represents the amount of money in dollars Tilly earns for 39 weeks. So now we're told what W is. It's 39. So it's kind of like us. I don't know what has changed about Zoom, but I'm not able to write on the screen. So yeah, I hope you guys still get. I love writing because I feel like it clarifies everything, but we'll make it work. So if it's P times W as our expression, then, and we have P as, we have W as 39, it's going to be 39 times P. So it is a 39P. Okay, so the concept is just multiplying by the rate of change. If it's if it's P dollars for every hour, we would have to multiply the number of weeks by the number of hours because you're getting that amount of money for every hour that is worked. Yeah. Does that make sense? Does anyone still need clarity?
No worries,
No.
I understand now.
All right, great. Okay, so this is kind of like a very basic example of using the y is equal to mx plus c, but it also shows how you can come up with your own equation from the information that's given. And that is always helpful. It just like puts everything together. Yeah, it just puts everything together. Wait, let me try something. I don't know. I really want to be able to write on the screen. So let me see if I can share a document instead of the page. Let's see. This is very strange. This is very... Can you guys see the test on my screen?
No.
Sorry?
Yeah.
All right.
I can see that.
Okay. Well, we'll just use what we have. Okay. So let's go to the second question. See. Okay. Second question says the solution to the given system of equations is x comma y. What is the value of y? So before we even solve this question, the first thing I want you to notice is you've been told what you're looking for. And so it's also important to analyze how each method works, because we said for elimination, the one you eliminate is not the one you're finding. But for substitution, the one that you make the subject is the one you're finding. So that's something to keep in mind as you go through. So let's say you are just looking at this for the first time. What's your first instinct? Would you use substitution or elimination?
Substitution. First thing
Substitution?
I'll do is manipulate the top equation.
You would what?
First thing I'll do is manipulate the equation at the top to get x equals 4. And then
Okay, okay.
Y.
So make x the subject and then substitute in the second. That would be, so we have both elimination and substitution. This is very interesting because this has both of the characteristics we talked about. Number one, we said if one of the coefficients is equal, you should use elimination because then you can directly add or subtract. And then we said for elimination, if one of the coefficients is 1, then you can make it the subject of the formula. So you have both qualifications here. But I want you to keep in mind which one you're finding. You're finding y, okay? So we had a suggestion of using the substitution method, which would mean you making x a subject. So that would be x is equal to 4, and then plugging it in to the x right here.
Which yields 6.
And that would give you, okay. So that would be So that would be 6. Thank you. So that's B. So that would be, it wouldn't be so slow of a method, right? Because either way, after you plug in, you already have the value of X. So you would easily find the value of Y. But it's also the same as you just adding these equations. I think, in fact, I think that would be kind of faster, because if you look at it, we're eliminating X, which is what we don't want. And so already we're going to directly find the value of Y. So you can as well just add, because once you add 3 minus 3X is 0, you're left with Y, 12 minus 6 is 6. So there's no need to even like put the same ones on the same side and all those extra steps that come with using substitution. So both of them are fast, especially because of the way the question is phrased, but just keep in mind that you can also use elimination, especially because these are equal, the 3X and the 3X. And another thing is sometimes they try to outsmart you because they know which method would seem easier, right? Because of how these look, maybe you would automatically go for substitution and then find the value of Y. Then maybe they would ask you for the value of X, right? They're just trying to catch some people who would maybe forget to find Y and just put X as the answer. And especially because you have 3X is equal to 12, it's very easy to find the value of X. And then they ask you for Y. So just pay close attention to what is being asked. That would save you a lot of errors in your exam. Any questions?
No, ma'am.
All right, let's move. Okay, question 2. Oh, we actually went to question 3. Okay, now on question 2. For a training program, one rides his bike at an average rate of 5.7 minutes per mile. Which function M models the number of minutes it will take one to ride X miles at this rate? This is kind of similar to the first one because you have the rate of change. Sorry?
It's the only one that suggests a rate. First D.
C?
Twice D.
Twice B?
D.
D. Okay, I'm sorry. It's kind of hard to like hear exactly the letter. Okay, so we have a D. Does everyone agree? D. Okay, I see another D. Okay, great. This is great. This is great. So we've been told it's 5.7 minutes per mile. So this is our X. This is our M, right? We said it's our Y per X. And then we're asked which function models the number of minutes it would take one to ride X miles at this rate. So since it's 5.7, sorry?
Sorry, X A. I kind of misunderstood something.
Sorry?
Sorry, it's A.
A, okay. We have an A. Okay, so let's go through. Let's go through. So I told it's 5.7 minutes per mile, meaning that it takes this person 5.7 minutes to ride the mile. So this is definitely our, let's see, miles per minute. Minutes, okay, I see. This is switched. It's minutes per mile, not miles per minute. Okay, so it says which function M models the number of minutes it will take one to ride X miles at this rate. Okay, I see what they're trying to do. I really wish I could write on my screen. Let's see. Yeah, let me share the whiteboard and then I'll come back to this. Okay, so I told it's yellow is not very clear. Let me erase this. And you black. Okay. So I told it's 5.7 minutes per mile. And then the question is asking us the number of minutes it would take one to ride X miles at this rate. Another thing that you can use here is the dimensions, because whatever you calculate, the dimensions should make sense. So we know that we're trying to find the number of minutes it would take, meaning that the mouse should be able to cancel out. And they will cancel out if we're just multiplying 5.7 by x, right? So if you have 5.7 minutes every mile, if you multiply that by the number of miles, you're going to remain with the number of minutes. So it's going to be 5.7 times x. In this case, it's flipped around, which I see how the confusion can be. So I take back my statement about x always being about time, because in this case, x is not the time. We're told that x is the number of miles. That's the change that we're looking at. X is the miles. So that is definitely my bad. This is the first question I've seen where x is not the number of minutes. It's the number of miles. So I would say just look at each question on its own merit and see what the variable is. The variable in this case is the number of miles. And they've made that clear in the question, like for x miles. So it means that it now becomes minutes per mile, meaning that y is the number of minutes, x is the number of miles. So if we multiply the m by the x, we're going to get the y, which would be the number of minutes. And I probably overcomplicated this just because I'm trying to connect it to the topic of linear equations. Just this should be able to give you the answer. Just see, do the units cancel out? Or if I multiply them, what do I get? Of course, if it was like 5.7, this is minutes over miles, and then I divide it by the miles, that would be the same as multiplying by 1 over the miles, and that wouldn't cancel out. I would get 5.7 miles per minute squared, which is not what I want. So just this should be able to give you the answer. Yeah. Any questions on this?
No, I get it.
All right, great. So let's go back to the questions. Okay, so now we're looking at question 4. This is a very good question. So it tests the last concept that we covered. What is m, what is b? So it says this equation gives the speed s in miles per hour of a certain car t seconds after it began to accelerate. What is the speed in miles per hour of the car 5 seconds after it began to accelerate? So is it 40? Is it 43? Is it 45? Is it 55? What do you guys think? I see. 45?
Yeah.
Okay, so we have C. Do you guys agree?
Choice B. Choice B.
D?
Yeah.
All right, okay. We have an A as well. Okay, so this one is not really conceptual, but you understanding what the equation means is definitely helpful. So let's see, it says this equation gives you the speed in miles per hour of a certain car t seconds. So t is in seconds after it began to accelerate. So it means that for every second, you're moving 3 times faster, and 40 is like your base speed in a way. So what is the speed in miles per hour 5 seconds after it began? So you already have this equation. All you need to do is put the 5 where the, wait, let me do this again. The equation gives the speed in miles per hour. Oh, that's the thing. The hours and the seconds of the second car, t seconds after it began to accelerate. What is the speed in miles per hour of the car 5 seconds after it began to accelerate? This is a very interesting equation because it has hours and seconds. T seconds after it began to accelerate. T seconds. It's definitely not just supposed to be the 5. So does anyone want to explain the answer?
Yes. We just substitute the t for 5. 3 times 5, 15. 15 plus 40, 55.
15 plus 40 is 55, yes. Okay, great. I don't know, for some reason, okay, I think I'm just tired after the very long day. But okay, so if we multiply the 5 by the 3, that would give us 15. Add that to the 40, we do get 55. Thank you for that. Okay, so we have the T, which is in seconds, and the S, which is already in miles per hour. So all we need to do is substitute the 5. And like I said, you don't need to really understand the equation for you to come up with the answer, because you already have it, unless you're being asked what is 3, what is 40. And I'm hoping to find a question like that. Let's see if we can find one like that. Okay, this goes to different concepts. And again, you'll notice as you go through that these questions are kind of grouped. You saw that the first 4 questions were kind of linear equations. As you go forward, you have the Pythagoras theorem, other trigonometry, and like it progressively roughly becomes harder as you progress in the section. And I say roughly because it's not fixed that the questions will be harder, especially because some people find different things harder than others. But that will help you just to be in the right mindset, like to know that the more you go further in the section, the more work you have to do. So if you take your time at the beginning, that will definitely harm you, which is why my approach was starting from the end, starting from the hard questions, so that even if I do relax towards the end, I'm only left with simple questions. Though, of course, that wasn't the goal. Okay. Seems like this one only had one math section, or was I already in the second section? Okay. For the sake of not finishing your study materials, I will, let's see, this is the same one I'm going through. Oh, great. Okay, found it. All right. So there's one specific kind of equation I am looking for, but 2 looks interesting. So let's go through question 2. It says 4x plus 6 is equal to 18. Which equation has the same solution as the given equation? Is it 4x is equal to 108, 4x is equal to 24, 4x is equal to 12, or 4x is equal to 3? I see a C.
I'd say A.
A. Okay. Okay, so this still tests the concept of infinite solutions, though this is a much simpler question. But the concept is what you do to one side, you do to the other side as well, which is what we do when solving the equation, right? So you have 4x plus 6 is equal to 18. For you to leave 4x, because if you look at all the answers, 4x is alone on the left-hand side. And so if you subtract 6 from both sides, you're still going to end up with the same equation, but you're going to get rid of this plus 6, which is not there in the solution. So another thing that can help you is using the options to kind of see what you need to do, because this question isn't very straightforward. C, okay. Okay. Yeah, so that's definitely correct. So if we do subtract 6 from both sides, we get 4x is 12. So this is definitely the same equation. And like I said, it just means you've manipulated one to find the other. So in this case, we subtracted 6 from both sides to find the other. Any questions? Okay, so let's see. There's just one kind of question that I want.
Hold on a minute, please.
Uh-huh.
Yeah, I had a question.
Go ahead.
Instead of subtracting 6 from both sides of the equation, why I said A was, the thing is, what I did, I transposed the 6 over the equal sign. So it would be 4x equals 18 times 6.
You mean like you took the x to the other side of the equation?
Yes.
Oh, okay. I see what you mean. So the thing is, just the sign. The sign is what makes it different. So you have +6. If you want to take +6 to the other side, it becomes -6. It would have been different if we were dealing with the 4, which is part of the x, because then we have to either like divide or multiply by a fourth. But in this case, it's +6. So when it crosses the equal to sign, it just becomes -6. I don't know if that clears it up.
Yeah, I get what you mean, because if that would be, then the answer would I would have gotten would have been 4x is equal to -108.
If you subtract 18 minus 6,
No, I was saying that if I transpose, I didn't look at the sign, because if I did, I would have, the answer would have gotten would have been 4x is equal to -108.
wait,
Because the 6 would have been negative.
let me just make this a whiteboard. I feel like there's like, oh, sorry, let me erase this. I feel like there's like a small mix-up in the signs. So let me write this down. Okay, so we're dealing with 4x
You got no fuse here? Watch.
plus 6 is equal to 18. Okay, so whenever we want to do to one side what we do to the other side, it depends on the term that we're looking at, right? If you have +6, because you have to get rid of it on one side for it to be gotten rid of on the other side. So how do you get rid of +6? You subtract 6. It's going to be -6. And so what you do to one side, you do to the other side, which is why we said this becomes 12, because we subtracted 6. It would have been a different situation if we had like x over 6 is equal to 18. Because then we would multiply by 6, because that's what's going to get rid of the 6 on this side. If we multiply by 6, we would also have to multiply by 6 on the other side. So the transposing depends on the term that we're looking at. If it's just being added or subtracted, we only need to add or subtract. If it's being, in fact, let me put it this way, it's the inverse, right? If it's being subtracted, you need to add it to the other side. If it's being added, subtract it from the other side. If it's being divided, like this example, you multiply on the other side. If it's being multiplied, you divide on the other side. So basically doing the opposite thing for us to get the opposite thing. Like in this example, we had +6. So how do you get rid of +6? You subtract 6. So we would only need to multiply by 6 if it was being divided by 6. Yeah, I don't know if that clears it up.
Yes, it does. Thank you very much.
Okay. Okay, so I hope everyone takes the time to like practice through, because equations would definitely be on the SAT. That's like one of the default topics that you'll find. It might be more straightforward or not, but you will definitely find equations. Okay, so there's just one kind of question I want us to go through. So for that, I'll look for an old SAT paper, just because I didn't see any in the one we went through. Let's see. And I'm pretty sure every one of the old SATs should have tested that concept. So let me share my screen. So this is the old SAT practice test 1. And there's just one concept I want us to go through. Okay, question 4 there. Question 4 says, Kathy is a repair technician for a phone company. Each week she receives a batch of phones that need repairs. The number of phones that she has left to fix at the end of each day can be estimated with the equation P is equal to 108 minus 23D, where P is the number of phones left and D is the number of days she has worked that week. What is the meaning of 108 in this equation? So is it Kathy will complete the repairs within 108 days? Kathy
Choice
starts
B.
sorry? B?
Choice B.
Okay.
Kathy starts the week with 108 phones to fix. It's the only constant there.
Yes, great. Thank you. Does everyone agree with B, or do we have a different option?
I say B.
B, okay. Okay, I guess everyone agrees with B, which is great, right? So they've explained to us what this equation means, right? It says that those are the number of phones she has, this equation. So P represents what's left at the end of the day. So if the change is happening to the 108, it means that that's what she's starting with. And then we're subtracting 23 for every day that passes. So if you really understand the equation, it's very easy to figure out what the 23 and what the 108 represents. So in this case, let's go through the options. So A says Kathy will complete the repairs within 108 days. This is wrong because the days are D, and that's not being affected by the 108. That's a separate constant. Then B is our answer, right? Because that's what's being subtracted from. Then Kathy repairs the phones at a rate of 108 per hour. That would be correct if they use the 23, right? Because, oh, sorry, this is the days. That's wrong. D would be the one. Kathy repairs the phones at a rate of 108 per day because we know D represents the number of days. So if it was 23, that would be our answer, because then if we're subtracting 23 for every day that passes, it means that she's repairing 23 phones every day. Yeah, so it's all about seeing where the M is, where the X is, and then understanding what each one represents. And 6 is another example, so let's go through 6 as well. It says H is equal to 3A plus 28.6. The pediatrician uses the model above to estimate the height of a boy in inches in terms of the boy's age, A, in years, between the ages of 2 and 5. Based on the model, what is the estimated increase in inches of a boy's height each year? Is it 3, 5.7, 9.5, or 14.3?
14.3.
Okay, we have that's
No,
D.
I mean 9.5. Sorry, 9.5.
9.5. Okay, so that's C. Does everyone agree with C? Okay, so this kind of looks like a trick question just because you have different variables from X and Y. You have H and A. But I want you to keep in mind the Y is equal to MX plus C. So in this case, Y is the height, A is the X. So the years, and in this case, the years are in terms of time, right? So if we're adding 3 for every year, because this is the number of years of the boy, that's the age. So if we're adding 3 for every year, it means that each year it's increasing by 3, right? Remember that our M is our Y per X. So it's our Y, it's our height per year, because A represents the number of years. And if we're adding this to 28.6, it means that this is the height that the boy already had, right? So it's like he's starting off with 28.6, and then we're adding 3 by the number of years for every year that that the boy increases in height. So the whole thing is seeing what does A represent, why are we multiplying it by 3, and how that affect this equation. Yeah. Any questions?
No,
So
ma'am.
what do you compose the answer?
The answer would be A, 3, since we're multiplying 3 by the age in years. Okay, so it's all about the Y is equal to MX plus C. Let's see, I don't think we would be able to find another one, but let's try. Let's see the calculator section. Yeah, normally questions in the calculator section always require a calculator. Yeah. So again, for the sake of, oh yeah, here we go. Great. Okay. So this combines the concept of lines and the equation. And it says the graph displays the total cost, C, in dollars of renting a boat for 8 hours. What does the C-intercept represent in the graph? Is it the initial cost of renting the boat, the total number of boats rented, the total number of hours the boat is rented, or the increase in cost to rent the boat for each additional hour?
A.
Initial cost of renting the boat. I heard another A. Does everyone think it's A?
Okay.
Okay, great. So remember we said the y-intercept represents the point when x is 0, so the number of hours is 0, and so that would be the base charge or the initial cost of renting the boat. Okay, so this concept is tested a lot, and it's very easy to understand. I'm sure you've seen just from the short session we went through, and from, of course, what you guys have learned over the years, we're able to figure out all the questions we've gone through for equations. So those key concepts will remain the key concepts. Do you understand how to solve an equation? Do you know what an equation means, right? What is your M? What is your B? And that will help you figure out the questions that you solve. Okay, so that's equations. Again, I'll keep emphasizing that practice is very important. Like we've seen, all these questions we've gone through have been very different from each other. There are some that test the same concept in different ways. And so the more practice you do, the better you get at solving. So for math, don't spend time reading through this and like trying to understand. The understanding will come from you practicing. So just practice as much as you can and make sure that you cement every topic. So if from today what we've gone through, you see that, oh, I have some work to do in linear equations, then take time to understand linear equations. Just have that topic by topic approach. And this should help you in other sections as well. You should be able to identify where your problems are so that you're addressing those problems. And as you practice, another thing I'll emphasize is go through what you practice. I mean, if you go through a practice test and you get like, I don't know, 110 or 110, something like that. Don't just say, oh, okay, I'll do better next time. Like, try to go through your paper and see, okay, which questions did I get wrong? Which ones did I just guess on? Which ones was I doubting? Why did I get this question wrong? Did I not understand the passage? Did I not understand the equation? And the more you do that, the more you are addressing what's making you get those questions wrong. And that will definitely improve your score. So as you practice, always use your practice test as a kind of revelation. Try to see, why did I get this question wrong? How can I get it right next time? And that will definitely improve your score. Okay, so this is it for today. We've gone through linear equations. I hope this has either shown you how much work you need to do or shown you how much you are doing great. But either way, progress is key. So just keep practicing, just keep studying. And the more you do it, the more confident you'll become. And the more calm you'll be on the actual day of the exam. So yeah,
Thanks
are
for
there any
your
questions?
encouragement. Thanks for your time and thanks for a very great session.
Thank you. I really enjoyed the participation. Yeah.
Thank you very much for your time. To see you again next week.
All right. Have a great evening. I'm sure it's evening where most of you are.
Have a good rest of the day. See ya.
You too. Thanks.